Hello everyone. This time we are going to discuss about the module 5 or CE324, which is the solution to systems of linear equations. So I am Engineer Marty Plaza, your instructor under CAG Department of SEIA, USTPCDO. Okay, so the outline of our presentation will includes introduction, LU decomposition, then the LU decomposition through Gauss elimination. So, under numerical methods to solve linear system of equation, we have we call the direct methods and the iterative methods. This LU decomposition still belongs to the direct methods. So we have already discussed with the Gauss-Jordan method and also with the Gauss elimination with pivoting in module 4, which was discussed by engineer De La Peña, no? With the introduction of the matrix operations. Okay, so this time we are going to discuss about the LU decomposition. So just a review of triangular matrices. We have this what we call lower triangular matrix, wherein all the values above the lower triangle are zero, and in only the lower triangle including the mean diagonal has a non-zero value. No, so kana siya. So this forms a lower triangle with a non-zero value, while the upper triangle matrix is the opposite. All the lower triangle has a zero value, and the upper triangle including the main diagonal has a non-zero value. Okay? So, LU decomposition or factoring or decomposing matrix A into lower L and upper triangular matrices such as matrix A is equal to matrix L multiplied by matrix U. So, what is LU decomposition means is that you will decompose, no? You will factor out matrix A into lower triangle matrix and upper triangle matrix, no? As a product of lower triangle matrix and upper triangle matrix. So that's what we will be doing in LU decomposition. Okay? So this method is helpful when solving equation with the same coefficients matrix A but with different right hand side constant B. So according to matrix equation, we have this what we called AX plus B. Matrix A times X, which is X is the unknown, no, vector of unknowns, and B is the matrix of constants or vector of constants. It depends. Okay. Uh, so for example, we have this what we call systems of linear of equation. This is a systems of linear equation or linear system, and then it has been translated into a matrix form such as this. We have this coefficient matrix A, with corresponding row column position, and then we have this X, which is the matrix of the unknowns, and then we have this B, which is the matrix of the constant, which is simply A X is equal to B. No, so this is the form. And then from AX is equal to B, we will decompose A as LU. Okay? And then we will just substitute LU to the A. That's why what will happen is that it will be the matrix equation will become LUX is equal to B. Okay? So you will just substitute LU to A from the main equation or matrix equation AX is equal to B. So what will happen? It will become LUX is equal to B. And then we will just let this part UX as Y. And then we will just substitute y to ux, and then what will happen is that ly is equal to b. No? So this is what will happen. And then we will just focus in these two matrix equation in solving for the unknowns, okay, in a linear system. So what we will do is that we are going to solve y using forward substitution. So this ly is equal to b um, will be in this form. So we have this L11, L21, L22, L31, L32, L33, L41, L42, L43, and L44. So we will be using forward substitution to solve for y. So as you see, there is only one coefficient for in this row. It means that L11 times L11, sorry, L11 multiplied by y1 is equal to b1. No, so from that value, so we have this value for L11 and we also have this value for b1. We can now solve for y1. Okay? So that's why we have this y1 is equal to b1 over L1. You will just divide L11 in both sides to get this equation. Okay, so from that, you will then substitute y1, the value of y1, to this equation. So for in the second row, we can form equation L21 times y1 plus L22 times y2 is equal to b2. So the only in that equation, the only unknown is y2. And then y1 can be substituted, whatever the value of y1 can be substituted to the equation. Later on, I can show it to in the example. Okay, so and then so on and so forth. You will just do forward substitution. Okay, so given that you have done the forward substitution, we will now then do the given that you have all the values of y, no, so you already have all the values of y, we can now solve for x using back substitution. So this forward substitution is that's why it is called forward substitution, because you will start from the top to bottom. You will go forward. Okay? So from top to bottom. So this is called back substitution because you will start from the bottom to top. Okay, so your equation, you will solve using the equation u44 multiplied by x4 is equal to y4. And then just by dividing u44 on both sides, we will have x4 is equal to y4 over u44. And then you will just continue solving upwards until you solve for all the values of x's, no? So given that you solve for all the values of x's, you are done solving the linear equation. Okay? So how do we decompose matrix A such that matrix A is equal to matrix L multiplied by matrix U? So we can use LU decomposition by Gauss elimination. So let's say we have this matrix equation. We have this U is equal to A11, A12, A13, A14, A22, A prime 22, A prime 23, A prime 24, A double prime 33, A double prime 34, and A triple prime 44. And then L is equal to 1000, M21, 100, M31, M32, 10, M41, M42, M43, 1. And what will we do is that we will do forward elimination using pivot row and then adding and subtracting rows. Okay? And then we can write the value of L explicitly while we're solving for U matrix. Okay? So, I will just show you later on in the example. So, this method is also referred as the Doolittle decomposition. Okay? So, this element in L must have a diagonal which is equal all elements to be equal to 1. So, Mij are the multipliers to the pivot equation used to eliminate the elements below the pivot coefficient. So, for example, we have this systems of linear equation uh, being 9x1 plus 3x2 minus 2x3 is equal to 3. Then 6x1 minus 4x2 minus 3x3 is equal to negative 20. Then we have 2x1 minus 6x2 plus 5x3 equals to 20. And then we can now translate that linear systems of linear equation into the coefficient matrix containing 9, 3, negative 2, 6, negative 4, negative 3, 2, negative 6, and 5 multiplied by the coefficients of matrix of the unknowns x1, x2, and x3 equals to the constant matrix 3, negative 20, and then 20. Okay, so first thing that we have to do is to decompose this matrix A into LU. So to decompose, um, let's have this matrix A. So matrix A is equal to 9, the matrix containing 9, 3, negative 2, 6, negative 4, negative 3, 2, negative 6, and 5. And then we will just, as we've learned in the Gauss-Jordan elimination, and also in Gauss pivot, no, pivoting. So elimination pivot row. So we will just let the top portion to be the pivot row. Okay, and then we will just apply Gauss-Jordan elimination by dividing the first element, first non-zero element to the corresponding um, by the corresponding element at the pivot row. So that is 6 over 9. Okay? And then we will just subtract row 2 to the product of 6 over 9 and the pivot row. Okay? That is R2 minus 6 over 9 R1. And then the result of that will be uh, written into the R2 for the transformation of our matrix. Okay? And then for the third row, same also, we will just subtract row 3 into the product between 2 over 9 multiplied by the pivot row, R1. Okay? That is R3 minus 2 over 9, R1, and then it will be written in the third row. Okay? So what will happen is this. Okay? And then, so, um, you will just calculate each of the values. So, for example, we have this R2 minus, or row 2 minus 6 over 9 times R1. Then it will be in row 2. So, okay. So, what we'll do in the calculator is that we will just input this. We will just let R2 to be, elements of R2 to be alpha A. And then, 6 over 9 multiplied by B. Okay? Where B is the pivot row. Elements of the pivot row. So, let's try to the first column of row 2. Okay, so calc. So, that is 6 minus R1 being 9 Okay, so that is 0. So that's 0. There's 0 here. That's why there's 0 here. And then in the second column, we will just let A be equal to negative 4. And then B be equal to 3. Okay? So that's negative 6. And then calc, we have negative 3. Then negative 2. That is negative 5 over 3. Okay? And then for the third row, we will now change our equation because this will become 2 over 9. And then A, instead of R2 or row 2, that will become the elements of R3. So for the first column, that is, calc 2 for the first column over 9. Okay, so that is 0. Then calc negative 6 over 3. So that is negative 20 over 3. And then calc 5, then negative 2. So that is 49 over 9. Okay? So, given that we have already solved for the next, no? Na zero, we already have 0 at this portion, but what we need is that we also need to make this part to be 0 because we want this matrix to become a upper matrix, no? Ano siya, as we have discussed in the previous slides. Okay? So, okay. So, what will we do next is we will um, change the pivot row. Instead having the pivot row at the first row, we will use the second row to be pivot row now because the first element, it has the it, topmost, no? Topmost row that has a um, non-zero at the first, I mean at the second column, no? So at the first column, all the values here are zeros. So the topmost column with that zero element in the first column must have the must be the pivot row. Okay? Because we will not be changing this, no? This will remain as is. So that's why we'll be using it as a pivot row. Okay? So just like what we do in the first step, we will just let it to be the pivot row, and then we will just subtract row 3 to the product of the ratio between negative 20 over 3, no, over negative 6, which is the first than zero element, no, of both rows. So that's why it will become R3 minus negative 20 over 3 over negative 6 multiplied by R2. So same method, we will just edit this and then we will just input. Okay, so we'll just put this value. Okay, so, okay, and then this will become negative. So this is negative 20 over 3, then divided by negative 6. So we'll just calc that, and then we'll just input A being negative 20 over 3, and then B being negative 6. So that is 0. Okay, and then okay, so that is 0. So here, that's why there's 0 here. And then um, so for the last element at column 3, so we will just let A to be 49 over 9, and then B to be negative 5 over 3. Okay? So that is 197 over 27. Okay. So, as we said, we will explicitly solve for L while we're solving U. So, what are those values of L, no? Matrix L. So, this is the values of L. So, where this value came from, no? Kaning 2 over 3, 2 over 9, then 10 over 9. So, it came from this, no? This value, the multiplier of the row, no? Corresponding row. So, for example, for this row, no, of L, which corresponds to this row, this element of L corresponding to this element is equal to this 6 over 9. You will just divide this value, you will just take note of this value, 6 over 9, and then put it in here. Okay, so that is 2/3. Okay, so that is 2/3. So for um for this element also, that is just 2 over 9. So this is 2 over 9. So 6 over 9, you will just simplify that, and that will become 2/3, and then 2 over 9 is just 2 over 9. Okay, and then for this element, you will just use this value, no, the factor. So that is just negative 20 over 3 over negative 6, or just simply 10 over 9. You will just this will just become negative, divide by negative is positive. 3 times 6 becomes 18. So that is 20 over 18. So simplify that by dividing both numerator and denominator by 2. So this will become 10 over 9. Okay? So, and then diagonal to be 1. Then all the values upward will become 0. No? And that then you will have your L. So let's check if A is equal to LU. So let's check. So using calculator and the matrix function of our calculator, we will just let L to be our A, matrix A, being 3 by 3. Sorry. Matrix A to be 3 by 3, so that is 1. Then we will just input all the values. So 1, 0, 0, 0, then 2 over 3, then 1, 0, 2 over 9, 10 over 9, then 1. Okay? And then we will just also input the value of, or the matrix U as B, no, as matrix B. So that is shift then 4 for matrix. Then we will choose data, that is 2. Then we will choose matrix B. So matrix B being 3 by 3. So that is 3 by 3. Then we have 9, 3, negative 2, then 0, negative 6, negative 5 over 3, then 0, 0, then 197 over 27. So you will just be careful in solving this kind of equation, because there's a lot of tendency that you will commit mistakes, no? So there are times that you will come up with a different matrix, and if that happen, there's something wrong with your decomposition, so you will start all over again. So that's why while you're doing LU decomposition, you must be extra careful. Okay, so let's multiply matrix A and matrix B. So that shift 4, then 3, multiplied by shift 4, and then 4 for matrix B. So what we have is 9, 3, negative 2, 6, negative 4, negative 3, 2, negative 6, and 5. So that is correct. So, okay. So, okay. So, and then from the, we're not yet finished, no, we're just done. Our main goal is to solve for the values of the unknowns, which is x. So, from the, as we have discussed earlier, so we will now first solve for y using forward substitution, and then after we solve for y, we will now solve for x using backward substitution and this matrix equation. Okay, so using forward substitution and ly is equal to b, we have this equation. Okay, and then you will just do forward substitution. So that is just for the first row we have 1 and y1 that is equal to 3. So that we have now a value for y, so that is 3. And then for the second row, we have 2/3 y1 plus 1 y2 is equal to negative 20. Okay? And then we will now solve for y. Uh, we will now solve for y using the value of y1, no? And in this equation, the only unknown is y2. Okay, so by that we can now solve for y2. Okay, so you will just substitute y1 here, and then you can now solve for y2. Okay, so for the third row we have 2 over 9 y1, then 10 over 9 y2, and then y3, okay, which is equal to 20. And then whatever value we'll have for y2, you will just substitute it here, and also the value of y1, you will just substitute it here to solve for the value of y3. In result, we have y1, y2, and y3 being equal to 3, negative 22, 334 over 9 respectively. So given that we already have the value for matrix y, we can now solve for x using this backward substitution. Okay? So we have ux is equal to y being this equation, matrix equation, and then we will just do backward substitution. So at the bottom row, we have this 197 over 27 multiplied by x over x3 equal to 334 over 9. And then we will in the second row we have negative 6x2 minus 5 over 3x3 is equal to negative 10. Sorry, this is not negative 10. Try this. Let me change it for a while. For a second lang. Okay, so that is equal to negative 22. So, and then in the top row, whatever the value of you can solve for x3 here, you will just substitute it in this equation, and then you will solve for x2. And after you solve for x2 and x3, you will now solve for x1 using the top equation. So this top equation is from the top row. So we have 9x1 plus 3x2 minus 2x3. Okay? Which is equal to the constant 3. Okay, so from that, you can now solve for x3. So what you will have is this value. So you have x1, x2, and x3. Okay? See, so okay, so you can use calculator to solve for that. So let's have an example on how to solve for that. So you will just use comp. Okay, so for the first equation we have 197 over 27 equal to 334 over 9. So this is just alpha x. So we will just shift solve. We will solve for x. Then that is 5 point 0 um, 86. So I think there's some error here because that's supposed to be 6. But what happened? Okay, let me check for a minute. That's supposed to be 6. 197 over 27 multiplied by, divided by 334 over 9. Oh, what happened? So, okay, so there is a um, mistake now with the value. Instead of writing it as 334, we will write it as 394. So let me edit this portion. So this is supposed to be 394. Okay, so you'll just let it to be 394. Enable for us to solve for the correct answer. Okay, so that is just a typo error. And then, okay, so from this equation, you will just input the 197 multiplied by, sorry, this 197 over 27 multiplied by alpha x, because that is our known, equals to 394 over 9. So that is, we'll just solve for x. So our answer is 6. And then since 6 is equal to x3, we will just let it be c. Okay, in the calculator. Just to note that these values are a, b, and c. Okay, so let's shift then store it to c. Okay, and then at the second row we will now solve for x2. Okay, so what will happen is we'll just input in the calculator -6, then our unknown x. Okay, then minus 5 over 3 multiplied by alpha c, which is our x3, then equals -22. Then shift solve, our c is 6, then solve for x. Sorry. Okay, so we'll just put 0 here. Okay, so our answer is 2. So we'll just let it be stored to be. Okay, because that is x2. Then to solve for the top row, we have 9 alpha, our unknown x, plus 3 alpha b minus 2 alpha c equal to 3. Okay, then shift solve for those values. So we'll just equal for that. Then we have 1. Okay, so try to solve it on your own and practice this method in order for you to have a faster computation. Okay, so that's it for the example using 3 by 3 matrix. And if you want to challenge yourself, you may try to solve this example. Try to analyze the process. The process is still the same, but you cannot now use a shortcut in calculator and in checking for those values. So you still have this pivot row, and then you will just um, decompose this into upper and lower triangle, and then you will use the result of this using Gauss elimination, and then the corresponding factor you will just input it into the LU. So then this is the result. Okay, so try to analyze it in your own. uh, try to um, study it and then compare it with my example. Okay? Or try to solve it on your own without looking in the example. Okay? So check if the A, and also you have to check for if it is equal to LU. Then we will now solve for y using this matrix equation. Then you will also solve for x using this equation using backward substitution. And then okay, so same procedure. And then you will have this y, and then using that y, you will do backward substitution using this matrix equation to solve for x. Okay. Okay, so okay, so I think that's it. So okay, so there's an alternative method in decomposing LU, no? So what we do in our example is we're using Gauss elimination. If we do it in reverse, that is called Kraut's method. Okay, so if we are using Dolittle, I mean Gauss elimination, which is also called the Dolittle decomposition. Okay, so another method is the Kraut's method, okay, which is the inverse or reverse to that case. Okay, I think that's it. So hopefully you get something from our discussion and try to solve it in your own. By the way, I will be providing some practice quiz for you to try out. Okay, so thank you. God bless.